All right. This video is about 7-5 proportions in triangles. Sorry about the image here. I know it's a little bit blurry. I was unable to get the full reteaching to upload without a bunch of holes in it. So I just had to use the copy of the foldable that we use in our face-to-face classes. So face-to-face classes are going to probably appreciate this because this is what you're used to looking at anyway. All right, so 7-5 proportions in triangles. Okay. The side splitter theorem states that the proportional relationship in a triangle in which a line is parallel to one side while intersecting the other two sides. So there's a couple of theorems here and then a bunch of practice exercises. Okay. So looking at these three situations, here we have a triangle where we have a line drawn that is parallel to one of the sides of the triangle. Here we have several parallel lines that are crossed by a couple of transversals. And here we have a triangle that has a ray that is bisecting an angle. So we have an angle bisector drawn in there. These are our three different situations that we're going to be working with today. Let's go ahead and tag this like I do usually before I start the videos. And I did. I don't know what happened to it. So y'all just get to watch me tag it. Super fun, right? Completed. Okay. All right. So looking at theorem 7 for the side splitter theorem, this says in triangle ABC, segment GH or line GH is parallel to line AB. GH intersects BC and AC. The segments of BC and AC are proportional in the sense that this proportion is correct. AG over GC equals BH over HC. That's the side splitter theorem. Okay, the corollary to the side splitter theorem extends the proportion to three parallel lines intersected by two transversals. So in this case, we see that AB, CD, and EF are all parallel to each other. And you can find X using a proportion. So these parallel lines cut these transversals into proportional parts. So 2 over 7 equals 3 over X, and then you can just cross multiply. So the third situation we're looking at here is the triangle angle bisector theorem. When a ray bisects the angle of a triangle, that ray divides the opposite side, which in this case is DF, into two segments that are proportional to the other two sides of the triangle. So here in triangle DEF, ray EG bisects angle E. So that means the lengths of DG and GF, sorry, that's not right in that writing there. Let me fix that. Okay. The length of DG and GF, okay, are proportional to their adjacent sides, which are DE and EF. So that one's wrong too. Sorry about that. DE and EF, okay, such that DG over DE equals GF over FE. That's correct. That proportion is correct. So to find the value of X, we would set this up. 3 over 6 equals X over 8. That is also correct. So you just cross multiply and solve it. So let's practice a whole bunch of these. That's pretty much the rest of the lesson. These, by the way, are numbers 1, 2, 3, and 4. I don't know why the numbers didn't show up. This is number 1. We can call this one number 2. Call this one number 3. And call this one number 4. Okay. All right. So this is use the figure at the right to complete each proportion. So this first one is looking at MN and SR and LM. Okay, so the one that looks like it's missing here is RQ. If I said RQ over MN equals SR over LM, that would work. Okay, so we're going to go with RQ. So if you have highlighters or colored pencils or something that you can use to write over these, that might be helpful. Okay, so I'm going to change color on each one of these so that it might help you see how I'm getting my information here. Okay, so 1 is purple. We'll make 2 red. Okay, 2 is working with NO, which is right here, and it's working with LM, and it's working with SR. Okay, so hopefully you can see that the missing piece here would be QP right here. Put a couple of dashes in there. So 2 is going to be QP. And then let's look at the whole proportion the way it is. Not a lot of space here. NO over QP. I think I put R right there. That's not R. QP. NO over QP equals LM over SR. Okay? So, and this may make more sense to you when we start putting numbers to it. Let's make this one green. Here we're dealing with MN and RQ. So here's MN. Here's RQ. Okay, and then it says something over QP. Here's QP. So if we're dealing with MN over RQ, then the one corollary to QP would be NO here. So this is going to be NO. NO over QP. And one more. We haven't used blue yet, so let's use blue. Okay. All right, this one says SQ over LN. SQ is this entire piece here. SQ over LN. Okay, that's these two pieces together also. Equals RP. RP. So it's from R to P here. Over, and this would correspond to it, MO. MO. I almost couldn't see what I was supposed to be drawing on there. All right, MO. Okay, so let's work with the ones that are putting some numbers to this to help make this make a little more sense to you. By the way, virtual students, when you are doing this on your own, please make sure that you are making your own copy of this and doing your own work. You can't just save mine or use what I saved. Make sure that you're putting your own flair to it. You can use colors also, but make sure that you are showing all the work and not just putting answers down. All right, so number 5, this is solve for x. So this looks like 5, 6, and 7 are those problems where we're working with the angle bisector here, where the piece over the side equals piece over side. Okay, so let's set these. We can set all three of these up at the same time. So we can say piece over side, or x over 3, equals piece over side, or 4 over 6. Okay, I'm just going to go ahead and set them all up. X over 3, 4 over 6. Okay, so here we're going to have 8 over 12. That's piece over side. 8 over 12 equals piece over side. Piece is 6 over x. This is a piece. This is a side. Okay, piece over side equals piece over side. Don't worry about the right angle. It's fine. So here we have x over 3 equals piece over side, or 2.5 over 5. Okay, and again, I've said this a few times in the in-person classes. I don't know if I said it on the virtual class or not. So if you can easily see a pattern, then you're welcome to use that, okay? Cross multiplying always works, but look here. I have 3 and I have 6. If I just multiply 3 times 2, if I do the same thing to the top, then I can, it's kind of like a little shortcut. What times 2 equals 4? Since 2 times 2 equals 4, I know that x equals 2. If you don't see a pattern, cross multiplication always works. Cross multiplication here, x times 6 would be 6x. And 4 times 3, of course, is 12. Divide both sides by 6, and you get 2. So that still works. Okay? Same process here. I don't have a quick and easy multiplier here, so I'm just going to cross multiply. 8 times x is 8x. Equals 12 times 6 is 72. And I'm dividing both sides by 8. And those of you who are keen on your times tables will be able to see that x equals 72 divided by 8 is 9. Yay. Okay. And this last one here. Again, I don't have an easy multiplier here, so I'm going to cross multiply. 5x, or x times 5, which is 5x. And then 3 times 2.5. When I see things like this, I think of money. 2.5 is $2.50 multiplied by 3. Well, 250 multiplied by 2 is $5. $5 and another 250 is 750. 7.5 or 750. Or you could just multiply it out. And then dividing both sides by 5 gives us... 5 goes into 7 one time. Put my decimal place in there. 2 left over, and then bring down the 5. 25. 5 goes into 25 5 times. Okay, so I have 1.5 there. All right, so there's 3 examples with the angle bisector. So these next 3 you can see deal with a segment inside the triangle that is parallel. Actually, we have 4 of these here. 8, 9, 10, 11. A segment that is parallel to one of the sides of the triangle. So if we look up at that example here, we can see that that segment inside the triangle cuts the sides into proportional pieces. So this said AG over GC equals BH over HC. So let's employ that concept down here. Switch up some colors. Let's go red. Okay. Nope, not orange yet. Okay. All right. So we know these pieces are going to be proportional. So we're going to start this with 1 over 3 equals 1.5 over x. Make sure that when you set up your proportions, you are being consistent. Here's what I mean by that. Notice up here that I put x over 3 and I put 4 over 6. If I had said x over 3 equals 6 over 4, that would be wrong because I need to make sure that I'm setting this up consistently. I used a piece over a side every time. Piece over side. Piece over side. Piece over side. Just pick something. If you want to say side over piece, that's fine. You just got to do that on both numbers, both ratios. So you could have said 12 over 8 if you also said x over 6. Same thing here. I'm starting with this bottom piece, 1 over 3. So I'm going to start with the bottom piece here, 1.5 over x. You could just as easily say 3 over 1 equals x over 1.5. So if I flip this whole thing over, it would still be true. Okay, so I'm going to move left to right on number 9 here, x over 4. I'll start off from the left. X over 4 equals, and again, I'm going to move left to right and be consistent, 2 over 3. Okay. And then the setup for number 10, again, I'm going to start with the leftmost one. So I have 6 over 4 equals, and if I'm starting with the leftmost one, I'm going to start with x over 4.8. Doesn't look like I have any real easy multipliers here. So we're just going to have to cross multiply on each of those. But let's go ahead and set up number 11 first. Left to right, 2x over 15, 2x over 15 equals, and here I have x plus 2. Oh, that's a binomial, so I'm going to put it in parentheses so the parts don't get away. It's a lasso. Keep them together. Okay, so I have 2x over 15 equals x plus 2 over 12.5. Okay, so all I need to do now is cross multiply with each of these. What color? Wish y'all could talk to me and y'all could have input here. We're going to go purple. Okay, so when I cross multiply here, I have 1 times x, which is just x, so that's fortunate. So all I need to do then is 3 times 1.5. 5 times 3 is 15. Carry my 1. 3 times 1 is 3 plus 1 is 4. And I have my 1 decimal place in there. X then is 4.5. Okay, cross multiplying here. X times 3 is 3x. And I would highly recommend that y'all pause this and give yourself a chance to work these out and see if you can get them. Then unpause it and watch me work them and see if you did it right. It's a great way to double check and make sure that you got this. X times 3 is 3x. 4 times 2 is 8. So then I'm just dividing both sides by 3. And you get 8 over 3. And you can change it to a decimal or you can change it to an improper fraction. Let's do both. Improper fraction. 3 goes into 8 2 times. 3 times 2 is 6. So you have 2 left over. So it's 2 2/3. Hopefully you know that a third is 0.3 repeating. So 2/3 is 0.6 repeating. So I have 2.6 with the 6 repeating. I do want to point out that all 3 of these versions of the answer are correct. They're just in different forms. Okay. And here I have, when I'm cross multiplying here, I've got 6 times 4.8. Okay. So 6 times 8 is 48. Carry my 4. 6 times 4 is 24 plus 4 is 28. So I've got 28.8. Don't forget that decimal point. Try not to lose that. Equals, and I have 4 times x, which is 4x. So the last thing I need to do here is divide both sides by 4. Divide both sides by 4. Okay. Okay, so when I divide both sides by 4, see 4 goes into 28 7 times. 7 times. Okay. 7 times 4 is 28. I'm going to bring down my 8. And 4 goes into 8 2 times, so I end up with just 7.2. Right. Let's save here real quick. We just got our last 3. All right, so when I'm cross multiplying here on 11, I'm glad I left myself a little more room. I've got 2x times 12.5. Well, 2 times 12.5 is 25. So I've got 25x equals, and I'm going to have to distribute 15 through this parentheses. 15 times x is 15x. And 15 times 2 is 30. So I'm going to subtract 15x from both sides. That makes that one go away. And that leaves me with 10x equals 30. So my last step here then is divide both sides by 10. And I get that x equals 3. My pen seems to be getting sluggish. Okay, I have one of these that are using the parallel lines, then I have another angle bisector one. I'm going to go back to the same colors that I did with the angle bisector one just for consistency. Okay, so I'm going to do 13, then I'll come back to 12. Remember on 5, 6, and 7 with the angle bisectors, I was using piece over side equals piece over side. So the piece here is x minus 1. And I'm going to keep that in parentheses so it doesn't get away. Over the side closest to it, which is 12. Okay, equals. Again, I'm coming from the same place, so x minus 2, piece over side. X minus 2 in parentheses so it doesn't get away. Over the side closest to it, which is 9. Okay. All right, so when I cross multiply here, and I did this in green on the other ones, I'm going to be consistent and do the same. Okay. I'm going to multiply 9 through the parentheses here. Maybe I can type this out. Can I type this out? Try typing this out. Okay. Make it a little bit quicker and a whole lot prettier. X minus 1. Yep. Equals 12 times x minus 2. Okay. So when I distribute through the parentheses, remember that you need to multiply times every term in the parentheses. So this 9 is going to be multiplied by the x and by the negative 1. This 12 is going to multiply times the x and times the negative 2. Okay? So, continuing to type this out, I've got 9x minus 9 equals 12x minus 24. Then subtracting 9x from both sides. Subtract 9x from both sides, and I have negative 9 left on this side. And then 12x minus 9x is 3x minus 24. Now I'm going to add 24 to both sides. I'm going to have to kind of scooch everything over a little bit so I'm not running into that triangle. Okay, adding 24 to both sides. So 24 minus 9. Well, if I said 24 minus 10, that would be 14, but that's taking away one too many, so it's going to be 15 equals 3x. I'm just dividing both sides by 3. Then I get that x equals 5. And that's it for that one. Okay, so we just have 12 left, and then we're going to move on to the next section. All right. These are in proportional pieces, and you can look back up here at in the side splitter theorem here. You can see that the parallel lines cut the transversals into proportional pieces. So they said 2 over 7 equals 3 over x. Same thing down here. It's just turned a little bit differently. So I could say 2x plus 2 over 8 equals 10 plus 5 over x. Okay. I am going to lay out a space to do that, and then I'm going to type. Okay. All right. So I've got equals that. Okay. I'm going to type because I think it'll be quicker and it'll definitely be prettier. 2x plus 2 over 8 equals 10.5 over x. I need a little bit more line there, don't I? Okay. Put a little bit more line in here. Okay. So when I cross multiply, might need to, oops, sorry. Make this a little bit smaller. How about a little bit smaller? 14 maybe? All right, so when I cross multiply here, I've got x times 2x, which is 2x squared. I'm going to have to write that out differently. Plus x times 2, which is 2x. I'm going to have that set equal to 8 times 10.5. Okay, so 8 times 5 is 40. So 0 carry the 4. 10 times 8 is 80, plus 4 is 84, so that's 84. Okay, so I need to go back in here and I need to draw in the squared. Okay, so then I would subtract 84 from both sides, and I have 2x squared. When I see that quadratic, I'm going to want to make this into a trinomial. minus 84 equals 0, and then factor it. Okay. So let's start off here by getting rid of my 2, factoring out my 2. Okay, so dividing every term by 2, I have x squared plus x minus 42 equals 0. And technically I would have 2 times all of that because I factored that 2 out. Sorry, 0, not 2. Okay, then I just need 2 numbers that multiply together to give me negative 42 and that add together to give me 1. Is it understood 1 here? Well, 7 times 6 is 42. So if I said x plus 7 times x minus 6, then if I did my multiple distribution to solve that, 7 times 6, oops, 7 times negative 6 is negative 42, but 7 minus 6 is 1. Okay, so my answers then would be x equals negative 7 and x equals positive 6. Let me give you a tip here. You can't have negative length. Okay? Since x stands alone as one of these lengths, we're going to go with our positive answer, which is 6. Okay? Sorry it's so crunched up together there. Hopefully you can write a little bit smaller on your paper. Okay, so I'm going to go back to red because I haven't used red in a minute, and it'll be a little bit easier to mark this. Okay, so on 14 and 15, it says that the bisector of angle A, meets BC at point N. So here we have bisector of angle A. So we have a ray cutting it in half. I'm going to show that with the little curves. Angle bisector meeting BC at point N. Okay? And this wants me to find the lengths of BN and CN, and it tells me in my original problem that AB is 6. That's 6. Okay. It tells me that BC in its entirety is 8, and tells me that AC is 9. Okay. All right. So, sorry. So I'm looking for BN and CN on this one. I need to check my time here. Tell you what, I'm going to stop this for a minute, and I'll come back to it in a part 2 because I think it's getting ready to time out.